The Riddle of the Earth, Chapter 9. Cometary Phenomena Approaching Perihelion. The 1882 comet was one of the most magnificent of late years. It was bright enough to be visible in bright daylight close to the Sun. On September 17, 1882, it passed across the Sun within 300,000 miles of the photosphere and dashed directly through the corona. Within 3 hours it swung around 180 degrees of its orbit and continued onwards with speed unabated. But the nucleus was interrupted, for within a month it broke into two centres of condensation, with a tail estimated at 100 million miles. Later along its track, 6 or more filmy debris were observed, which suggested that its career was finished. Yet judging from the elongated ellipse it followed, astronomers calculate its return in the middle of the 27th century. The spectrum of this comet revealed hydrocarbons, sodium and iron, while calcium and magnesium were suspected of being present. Sorry, not magnesium, manganese, sorry, my apologies. Calcium and manganese. The progress of this comet, like others, showed the enormous toll imposed by the Sun as the body tore towards it. This process of change is one that fascinates and awes the observer. The mass in nebulae become more excited every day. Its nebulous clouds are thrown off from the nucleus, which inhibits every evidence of extreme perturbation. Some of the words here are like old-timey words because this was written 100 years ago, so excuse me if I struggle with the pronunciation slightly. Newton estimated the heat of the comet of 1680 to be nearly 2,000 times that of red-hot iron. In such circumstances, every soluble is reduced to its primary and constituent parts, and the various minerals forming the nucleus are in a highly incandescent condition. Any solids colliding and scraping against one another, grinding or flaking according to the class of mineral. Yet even amid this awful chaos there is a certain order, for the materia, governed by the weight of its units or molecules, falls into line, such as boulders, clay, gravel, chalk and sand, when follows the gaseous tail according to the specific gravity of its gases and spreads perhaps over an area of millions of miles. If geologists would study this aspect of astronomy, they would perhaps revise their estimates of the origin of the sandstone and chalk hills in various parts. Chalk may be the disintegrated particles of mollusca, but they have been subjected to the ordeal of fire and sorted out in their former journey from some other world before they reached ours.